Problem 49, Quantum Mechanics. The question is, if a particle is represented by the normalized wave function psi of x equal to root of 15 a square minus x square divided by 4 a raised to 5 by 2 for minus a less than x less than a 0 otherwise, the uncertainty delta p in its momentum is. Here we have to calculate the uncertainty delta p in the momentum of the particle. The formula to calculate delta p is square root of the expectation value of px square minus the expectation value of px square. First, let us find out what is the expectation value of px. Let us write the given wave function psi, that is equal to root of 15 a square minus x square divided by 4 a raised to 5 by 2. Here the wave function is real, so we can say that psi is equal to psi star. Now what is dou psi by dou x? Let us take the derivative of psi with respect to x, that is root of 15 divided by 4 a raised to 5 by 2 into minus 2x. Now let us find out the expectation value of px, that is equal to minus ih bar integral minus a to a psi star dou psi by dou x dx. Psi star is equal to psi and we have evaluated dou psi by dou x. Therefore, the expectation value of px become minus ih bar integral minus a to a 15 by 16 a raised to 5 a square minus x square into minus 2x dx. We can see that the integrand is odd and the integral is symmetric. We have, for an odd function, the integral over symmetric interval is 0. Therefore, the value of the integral is 0. Hence, we can say that the expectation value of px is equal to 0. Now let us find out what is the expectation value of px square. To find px square, let us use the formula h bar square integral minus a to a d psi by dx square dx. So first let us write what is the modulus of d psi by dx square. We have already calculated d psi by dx in the previous section. Therefore, the modulus of d psi by dx square is equal to 15 by 4 a raised to 5 into x square. Now we can calculate the expectation value of px square. This is equal to h bar square integral minus a to a 15 divided by 4 a raised to 5 into x square dx. This is equal to 15 h bar square by 4 a raised to 5. The integral can be represented as 2 times integral 0 to a x square dx. That is equal to 15 h bar square divided by 2 a raised to 5 into a cube by 3. That is equal to 5 h bar square divided by 2 a square. This is the expectation value of px square. The expectation value of px square is equal to 5 h bar square divided by 2 a square. Now we have determined the expectation value of px, the expectation value of px square. Therefore, we can calculate the uncertainty delta p as square root of expectation value of px square minus expectation value of px square, that is equal to square root of 5 h bar square delta p is equal to square root of 5 h bar square by 2a square minus 0 square. This is equal to root 5 h bar divided by root 2a. Therefore, from the given option, option D is the right option.